Hey everyone, this is Dr. Chen, and I'm making a quick video on how to test a serial mediator model through a structural equation modeling framework. And so as you can see here in this structural model, we have four constructs. We are going to say conscientiousness as a personality trait. One of the big five personality traits is going to have a direct effect on PTSD symptoms due to COVID. And you'll also have an indirect effect through religious coping, degree of acceptance, and you'll have a downstream effect on PTSD as well. Notice here in this framework that conscientiousness is defined by 3 item parcels. I created these item parcels prior to this demonstration because there's a bunch of items in there, not just 3 items. For PTSD, that's measured with PCL5 that has 4 item parcels based on the 4 symptom clusters of PTSD. With religious coping, we've got 4 items, and with acceptance, we've got 4 items as well. So acceptance kind of refers to the degree to which one just tries to live with the situation, and then religious coping is just one's tendency to rely on religious types of methods of coping, such as prayer. With that being said, this is a model that we're going to test. Let's try to go to our studio for us to do this. So first of all, we need to upload the data set. If you haven't already, you could set the working directory. That's what setwd is. In order to set the working directory, to tell R to figure out where to retrieve the data set from. If you save the R Markdown file within the same folder as your data set, you don't need to do this. So we're going to use the read.csv function in order to import the file into the global environment. We're going to call this master. And so as you can see here, it has 157 observations with 26 variables. We're going to go ahead and delete that. Use the summary function. Get descriptives. About that, I'm sort of using templates here in making this video. You can see here that we have the minimum, maximum, median, mean values for each of the items. And so this should give you a bird's eye view of the variables in this data set. We've got the COPE indicators from 13 all the way through 60. We're skipping a couple because there's a bunch of other coping items in that measure. For PCL, we got PCL 1, 2, 3, and 4. These are the item parcels that I created before working on this project. And then we have item parcels from the Big 5 inventory as well. And so we have a number of sub-skills in here, such as openness to experience, extraversion. We're going to focus on conscientiousness. So that's BFIC2, BFIC3, and BFIC1. These are item parcels that I created that maps onto conscientiousness as a personality trait. So we need 2 libraries here. We need SEM tools for conducting the SEM, and we also need SEMplot in order to have a visual of the structural model that we are going to create. Notice here that T is capitalized and P is capitalized as well. I'm going to walk you through the syntax here. So first of all, we got to tell the computer how we are going to operationalize conscientiousness, PCL, religious coping, and acceptance as latent constructs. To do that, just say conscientiousness, and again, you can name this anything that is intuitive for you to understand what the latent construct is referring to. So in my case, it's conscientiousness being defined as, so that is equals tilde, BFIC1, that refers to the first item parcel, so right here, plus BFIC2, that's right here, and plus BFIC3, which is right here. PCL is going to be defined by the 4 item parcels. Religious coping is going to be defined by the 4 items, and acceptance is going to be defined by the 4 items as well. So that's the measurement model. Now we need to tell R what the relationships are between the latent constructs. So that's the structural model. So we got the A, B, C, D path. Okay, so A is referring to the relationship, the unidirectional relationship between conscientiousness predicting religious coping, predicting acceptance, acceptance predicting PTSD, and conscientiousness predicting PTSD. Now, this D pathway is also known as the direct pathway because it goes directly from conscientiousness to PTSD. The indirect pathway is going to be composed of 3 separate paths. We got path A, path B, and path C. And to get an index of the indirect pathway, we need to multiply pathway A with pathway B with pathway C. So pathway A, we need to specify what is pathway A. Well, pathway A is basically religious coping being regressed on. So when you just have a tilde, that means regressed. Religious coping regressed on conscientiousness. And the asterisk A basically means we're going to call this structural parameter A, because we need to refer back to this later when we want to tell R to multiply those pathways to get the indirect effects. So religious coping is regressed on conscientiousness. Acceptance is regressed on religious coping. PCL is regressed on acceptance, and PCL is also regressed on conscientiousness. So it's A, B, and C labeled accordingly. To get the first indirect path, to get the indirect pathway in this model, we just need to multiply A multiplied by B multiplied by C. Notice here that we're using an asterisk again. In this context, it means multiplication. In this context, it means that we're labeling this parameter, the parameter estimate as D. So it is IND1, you can call this whatever you want. I'm just calling this IND1 because you may have multiple indirect relationships. So IND1 colon equals to A multiplied by B multiplied by C. And then the total effect is actually going to be the sum of the direct effect. So that's pathway D plus A multiplied by B multiplied by C. So all in all, we're going to get 3 important indices here: the direct effect, indirect effect, and the total effect, which is the sum of the direct and indirect effects. We're also going to constrain the covariances between the latent variables to be 0 because we only want unidirectional arrows pointing from one latent construct to the other. We don't want bidirectional arrows. So I'm saying here PCL, its covariances. So it's covariance. So the tilde is covariance is constrained to 0 with conscientiousness. That means we don't want a bidirectional arrow between PCL and conscientiousness. And I do that for all other pairwise comparisons of the latent variables. Make sure you indicate that this is the end of the model by putting this single apostrophe here. So this is called SEM model. We'll come back again to this later. This is just me setting the seed. This can be any number. Because estimating the parameters is an iterative process, by setting the seed, the starting values to a particular value, you can replicate and get the same parameter estimates if we were to rerun this again. This one is more so actually relevant to when you're fitting the estimating the model. So how do we estimate the model here? Well, we create an object called SEM.fit. You can name this anything. And this kind of looks like an arrow pointing towards the left. But basically, it's this symbol followed by a dash. SEM is the function. SEM.model is calling this object that we just created, comma, data equals to master, the data set. And then we're going to use maximum likelihood as the estimator. There's a bunch of other estimators that we could use, but we will use maximum likelihood. Okay, so let's create a visual diagram just to make sure that the arrows and the relationship between the latent variables and the indicators are what we say they are. So this is where the SEM plot functions become really useful. So within SEM plot as a package, we've got the function SEM paths with P capitalized. And so SEM.fit is the model that we just fit. What labels equals to STD refers to standardized parameters. Layout, there's all kinds of layouts here that you can try, but this just happens to be a layout that works for this particular example. Feel free to refer to the tutorial on SEM plots to figure out what the other options are. And this is just me designating the margins from the bottom, left, top, and the right-hand side of the entire visualization. So I'm going to go ahead and run that. And this is what we got here. So we can see that we start out with conscientiousness. It has a unidirectional arrow, and it actually has the parameter estimate, the standardized parameter estimate there as well, pointing towards religious coping. And religious coping has a unidirectional arrow pointing towards acceptance. Acceptance has a unidirectional arrow pointing towards PCL. So this is exactly what we would want, actually. And we can see the respective indicators for each latent constructs as well. And these arrows here represent I believe it's the variance of the estimated variance of each latent construct. All right, so let's get check out parameter estimates. So we're going to use the summary function from the model that we just fitted. We're going to ask for standardized parameter estimates, and we want R square as well. All right, we'll come back to this in just a little bit because this is probably what most people are interested in. But usually I check for Haywood cases first. Haywood cases are parameter estimates that are out of bounds. This usually comes about when you have a model that is a poor fit to explain or reproduce the variance covariance matrix and the mean structure of your data set. And so sometimes it happens due to other reasons too, such as data entry errors. We just want to make sure that the model parameter estimates are are within bounds. So make sure that R square is less than 1. Make sure that the variances, the standardized variances, are actually less than 1 as well. And notice here that we've constrained the covariances to be 0, covariances between the latent variables. And this is what we're going to be interested in. And then these ones over here represent the factor loadings of the specific items or item parcels on their respective latent constructs. So we can see, first of all, that when we did the relationship between conscientiousness and religious coping, this is actually statistically significant. Pathway B is also statistically significant. Pathway C is also statistically significant. And pathway D, well, this is not statistically significant, maybe trending towards significance perhaps. So what this suggests is that as conscientiousness increases by 1 unit, the religious coping increases by 1 unit as well. And as religious coping increases by 1 unit, acceptance goes up by 1 unit, by 0.142 units. The effect size is smaller, and so is the significance. And then pathway C is also significant. As acceptance goes up by 1 unit, PTSD symptoms goes up by 0.43 units. So it does seem as though the specific pathways are significant, A, B, and C, but we shouldn't assume that the entire pathway is statistically significant. That's where we go down to IND1. This is where we can get the statistical significance of the entire indirect pathway, so A, B, and C, and it's actually not statistically significant. It is 0.065. So even though the individual pathways A, B, and C were significant, this entire pathway unfortunately is not significant. D, the direct pathway, appears to be significant. That's D right here. Well, actually, no, my bad, it's not significant. And so yeah, kind of a bummer in this particular example here, but that would be how you would get those parameter estimates for this particular model. You can also get the goodness of fit indices, which you were to pull for them using fit measures. CFI, where is CFI? CFI is 0.96, TLI is 0.96 as well, which is pretty good. REMC is less than 0.08, and the confidence intervals are less than 0.08 as well, which is pretty good. And then SRMR is so-so. That's not too great. So the global fit indices suggest a rosy picture of the model that we're trying to test over here. But I think the specific parameter estimates, especially the indirect effects, suggest that our model is not a very good description of how the latent constructs are related to one another. Now, I also have here another example where if we say wanted to fit a serial mediator model that's more similar to the model that Hayes has in his conditional process book, because now we don't just have one indirect effect, we actually have two other indirect effects. We've got A, B, and C. We've got A through E, and then we've got F through C as well. You can see over here that we have three indirect effects. And it's, again, not that difficult for us to add these things to the model. The measurement model is still the same. What we're adding are the paths. So we've got path A, path B, path C. And then we also have path E and path F as the other pathways as well. And so the first indirect pathway is A multiplied by B multiplied by C. The second indirect pathway, that is A multiplied by E. So that's A and E, to the conscientiousness, to religious coping, to PTSD. And then we got F and C. So that is from conscientiousness to acceptance to PTSD. The total effect is basically going to be the direct effects. So D plus ABC plus A times E plus F and C. We constrain the covariances to be 0 over here. This is called SEM.model 2. We're going to fit the model just like what we did before. Create a path diagram. And as you can see, this is a lot more parameters here. Let me see if I can actually find. Oh, there you go. It's right here. So we've got a lot more structural parameter estimates between our latent constructs. Again, I'll just kind of double check to make sure that the arrows are pointing in the directions that we expect them to be pointing to. And then check for Hayward cases, and to get the parameter estimates, do the same thing. Check the R squares, nothing less than 1. Variances, nothing, especially for the standardized variances, nothing more than 1 as well. And here we have the pathways A, B, C, D, E, and F. So you take these ones and put them over here, basically, in this particular diagram. And most importantly, most people are going to be interested in the first indirect effect. Is it significant? No. What about the second indirect effect? It does appear to be significant. So that is IND2. IND2 is referring to A multiplied by E. So that's A multiplied by E. To interpret that, you go back to the regression parameter estimate. So A is this one. So as conscientiousness increases, religious coping increases. So that's A. And then E, as religious coping increases, PTSD symptoms appears to increase as well, and that's significant. Now I will say this: it's not the best measures out there, honestly, in terms of religious coping. It's very general and very one-dimensional. There are some religious coping skills that are very helpful, and some that are harmful. And unfortunately, in this particular example, religious coping was just defined very, very broadly. So it's really hard to have a good interpretation of what's going on over here. But again, just for the sake of this demonstration, this would be how you would interpret any specific significant indirect effects. And it looks like the third indirect effect was not significant, but the total also was not significant. Was the direct effect significant? That's T. It was significant. As conscientiousness increases, PCL actually decreases, which is interesting. Okay, and you can get the global fit indices as well using fit measures. You can look at CFI 0.97, 0.963. So that's pretty good. REMC is pretty good as well, less than 0.08. SRMR is fairly good as well. So that'll be how you could test a serial mediation model if you're interested in getting these specific indices for the indirect effects. In some sense, it's kind of like path analysis, except we're talking about this in terms of a mediation model using the language that Hayes talks about when he talks about serial mediation models. So I hope this was helpful. I'll be posting stuff in OSF, all the files and materials that I'm using here in this video, so you can reference this and try to walk through the example on your own. And feel free to let me know if you have questions. Bye-bye.